What it do, Dream Team? Welcome back to the channel. Here we are with Australia dealing Russia a crushing blow. Let's see what happens in this video and how they dealt Russia a crushing blow. And if you happen to enjoy the video, don't forget to hit that subscribe button, smash the like.
Ukraine is about to receive a revolutionary weapon system that could redefine drone warfare, the Australian-developed Slinger. You've seen the devastating impact of drones in countless news reports and social media videos, wreaking havoc on buildings, vehicles, soldiers, and infrastructure. The Slinger system promises to turn the tide in the battle against swarms of low-tech lethal drones. But what makes the system so special? How does it work? And why is it so desperately needed on the Ukrainian front lines? Stay with us as we uncover the cutting-edge technology behind the Slinger, its unparalleled capabilities, and the strategic advantage it offers Ukraine in this high-stakes conflict. But to understand how the Slinger can turn the tide in Ukraine, let's first delve into its impressive technical specifications and capabilities. Developed by Australian defense company Electro-Optic Systems, the Slinger counter-drone system offers an elegantly simple yet highly effective solution to a complex problem. Weighing just over 700 pounds, this self-contained unit is a formidable drone killer. Its primary weapon, a 30mm M230LF Bushmaster chain gun, is complemented by a Belgian-made FN Mag 58 7.62 caliber machine gun. With a 150-round ammunition drum for the chain gun and customizable belted ammunition for the machine gun, the Slinger is ready for action. If fired simultaneously, the chain gun can shoot up to 200 rounds a minute, and the FN Mag 58 can shoot around 650 to 1,000 rounds per minute. That's quite a bit of lead going downrange toward a cheap quadcopter. But that's not all the Slinger can do. Beyond its robust armament, the Slinger boasts cutting-edge detection technology that ensures no drone goes unnoticed. Equipped with advanced detection tools, the Slinger can pinpoint potential drone threats with precision. Its four-dimensional sensor unit continuously emits lasers to measure distances accurately, working in tandem with its primary radar to find, fix, track, and destroy enemy drones. At the heart of the Slinger is the American-made EchoGuard electronically scanned array radar. This revolutionary radar system, typically found in much larger standalone units, has been miniaturized for compact use. The EchoGuard excels in finding, classifying, and tracking targets of virtually any size under almost any weather. Utilizing unique onboard software capabilities that assist the EchoGuard in differentiating even the smallest and fastest moving of targets, little can escape its gaze. But how does the radar work? As a phased array radar, it sends energy pulses in one direction at a time. These pulses coincide with the maximum area of coverage the radar can see and happen so fast it can give data throughout its whole field of view as close as possible to real-time. For the EchoGuard, it operates in the K-band frequency range of 24.05 and 24.65 GHz. This incredibly high frequency range is great for producing high-fidelity data at short ranges, just what the Slinger needs to do. In addition to having this great data while tracking enemy drones, the operator can set the radar to a 10 Hz search while tracking function even while the Slinger is engaging a target. This is a very valuable capability, since it allows the operator not to get sucked into the current problem and able to look ahead for the next threat constantly. Another great feature of this radar is its field of view, with the ability to scan up to 80 degrees high in the air with a 120-degree cross-section. The EchoGuard radar can provide more than enough coverage for the Slinger's own field of view, which is up to 70 degrees straight up and 10 degrees down. But how does the gun stay on target when shooting from a
That's what I was gonna ask, but geez, bro, this Slinger is ridiculous, bro. Yeah, I don't know nothing about the war between the Ukraine and Russia, and I didn't know it was still going on today, and what's going on and how it's going, and that Russia's, I guess, using all of these drones. But if Russia is using all of these drones, this Slinger sound like it's about to take them all out. It is the drone killer. You shall not use drones if wouldn't Ukraine get these Slingers. So Russia's gonna have to try to find a different way. Jesus, this Slinger sounds absolutely phenomenal. Technology these days, man. Technology is something else. But yes, answer this question.
Moving platform. Thanks to a gimbal system, the Slinger can stay on target no matter the shooter's speed or drone speed to within 1 milliradian. A milliradian is 1,000th of a radian, the angle that intercepts an arc equal to the circle's radius. In plain language, this means that the margin of error for the Slinger is so small, it's almost not even measurable. But how far can the Slinger really see? EOS testing data reveals that the Slinger can detect targets over 12,000 meters away with its daylight camera and more than 13,700 meters with its thermal imaging camera. While this information is sufficient for radar registration, high-quality firing solutions are achieved within 5,600 meters for daylight and 5,100 meters for thermal imaging. For higher quality data that can be used to actually shoot something down, a potential drone would need to fly within 5,600 meters of the daylight camera and 5,100 meters of the thermal imager. Once inside this range, the Slinger can begin engaging the target since the operator has enough information to know the drone's bearing, range, and speed. If the drone closes another 500 meters, the operator can even tell the exact make, model, and type of drone. However, drones are only one of the targets the Slinger can engage. Because of the multi-threat environment in which the Slinger system will operate, drones are not the only adversaries the operator might need to contend with. From operational testing of the system, the Slinger can accurately detect and engage vehicles at distances of over 3.5 kilometers, enemy soldiers at 2.2 kilometers, and some of the most common, smallest quadcopters at distances of just over a kilometer. Rounding out the Slinger system's main parts are a few other sensors and pieces of equipment that help it to operate. One of these is a wind sensor mounted on the top right of the unit that continually feeds wind data into the Slinger's algorithm. Controlling the Slinger is a 50-pound control unit situated inside the vehicle. This control unit is almost like a video game, where a user can accurately find, fix, and engage targets with the push of a button. Now that we've gone over a good bit of the technical details of the
So my question is, does Russia not have anything like this? This Slinger is absolutely a game changer. This Slinger sounds truly special, like Australia. Shout out to y'all for coming up with all this technology. This is insane. I know America helped, and Belgium, I believe they said, helped, but Australia built. This is sensational. This is truly the sensational, the abilities of this freaking Slinger, dog. Russia don't got nothing like this
system. The question still remains of how the Slinger is so effective at shooting down small drones. The answer to that question is not what you think. Before Electro-Optic Systems became a defense company, it was a trailblazer in Australia's space industry, pioneering the best way to track objects in near-Earth orbit up to 36,000 kilometers. But how are they able to do this, and why track objects in space? According to recent data, there are more than 29,000 pieces of space debris larger than 10 centimeters, 670,000 more than a centimeter, and a staggering 170 million pieces of space junk larger than a millimeter. And all of this space junk is not just standing still. All the debris is flying around in near-Earth orbit at speeds of around 18,000 miles per hour, about 7 times that of a bullet. When combined with the fact that around 6,000 satellites are orbiting the Earth at any given time, keeping track of this enormous amount of space debris becomes a big issue. Even the smallest piece of junk hitting one of these satellites could be catastrophic. EOS came into the field to help solve this problem. Founded about 40 years ago, the company has become Australia's and one of the world's leading experts in tracking small, fast-moving objects around the Earth. While the company does a lot of research to explore deep space, the primary focus has been crafting cutting-edge lasers and optics that can measure these very small but extremely fast-moving objects within 1 millimeter of accuracy. Because of the decades of experience in doing this line of work, it's no wonder that Slinger was a natural transition for the company to go from space exploration to defense products. Essentially, the technology on Slinger has been in development for decades in the space industry, and the company is now miniaturizing this technology to become a drone's worst nightmare. But of course, the company needs more than just powerful lasers and cool optics to track this fast space debris. It also needs extremely powerful software programs. While the exact capabilities of Electro-Optic Systems' computer algorithms are kept under wraps as a company secret, they are without a doubt powerful. After all, with their lasers tracking tens of millions and potentially more than 100 million objects at any given time of the day, the amount of data that the company is processing is, for lack of a better word, astronomical. To then be able to take this massive amount of raw data, sort it, process it, and then have a usable product in real time within a millimeter of accuracy takes some serious computing power. For Slinger, this software is at the heart of its capabilities. With the ability to intake a huge amount of data from its EchoGuard radar, Slinger then needs to make sense of this information on very small, fast-moving targets in real time for the operator to actually engage them. But how is Slinger adapted from a cool science project to military use? According to press releases from the company, the beauty of the Slinger is that it can be modified to practically anything with wheels. While the official contract Ukraine signed for 160 units has 110 being fitted to M113 armored personnel carriers and 50 going to Bushmaster 4x4 trucks, the Slinger can be fitted to almost any type of vehicle. When EOS showed off Slinger's capabilities at the firing range with live drones, operators fired the unit from Denali pickup trucks. With the ability to turn everything from a simple pickup truck to an armored vehicle to a tank into a mobile drone point defense system, Slinger's utility is really only limited by the operator's imagination. So why is the Slinger really needed in Ukraine? Since the full-scale invasion of Ukraine, the type of fighting has been ever-changing. Due to the absolutely massive casualties the Russians suffered in both terms of soldiers and material, they began looking for ways to preserve their combat power. As for Ukraine, since they've remained the underdog in this fight from the beginning, across all metrics like number of personnel, equipment, and economy size, they too have sought to expand their combat power in a realistic way. In the end, both sides ended up choosing drones to meet their respective needs. But how bad has drone warfare gotten? According to reports from the battlefield, the use of drones has become absolutely critical to how both sides fight this war. They perform a wide variety of functions on both sides. The first and most obvious of these is reconnaissance. Both Russia and Ukraine have bought or developed their own reconnaissance drones.
So Russia don't got that. I'm keep going back to my question, because if Ukraine's using drones as well as their main source of fighting, as Russia has had to switch because they soldiers and unfortunately I hate to hear about anybody being killed or dying, but casualties were too high for Russia. They thought it was going to be easier to invade Ukraine. Ukraine proved them wrong. So now both are using drones as their main weapon, and now Ukraine is getting this weapon from Australia that is basically a drone killer. It doesn't sound like drones can get past this. Russia doesn't have anything like this of their own.
This is because of the depth of Ukraine's air defenses and the strength of Russia's air force. Neither side can get an advantage in the skies. Because of this, both sides rely heavily on reconnaissance drones, since if they get shot down, it's a much better price to pay than a multi-million-dollar aircraft and pilot. While reconnaissance drones like Ukraine's UKR jet or Russia's Orlan do a lot of the long-range reconnaissance that is then fed back to higher headquarters, both sides also use larger attack drones. Russia has famously buddied up with Iran to procure thousands of so-called kamikaze Shahid drones, which are meant as one-time use drones that fly at fast speeds and pack a huge punch. To date, Russia has employed more than 4,000 such drones in its illegal conquest of Ukraine. Ukraine has also developed or procured a wide variety of armed drones. Most famously, it's used the Turkish-made Bayraktar drone and the domestically produced UKR jet UJ-22 biplane. But while these attack drones and loitering munitions have played a huge part in the fighting, their use is underscored by an even bigger threat: first-person view drones. Known for short as FPV drones, these small drones are the true menace on the battlefields of Ukraine. They serve various functions. The first of these roles is to serve as local reconnaissance drones. With a range of 5 to 20 kilometers, these small drones are perfect for local company-sized units to have their own intelligence-gathering tool at all hours of the day. In addition to this role, both Ukrainian and Russian artillery units use FPV drones to help spot their fires. While traditionally a forward observer would be embedded with forward units to report what he saw, now a forward observer can get a top-down view in real time and correct fires without playing a game of telephone on the radio. But despite these advantages, the true terror in FPV drones comes in their bomb-dropping capabilities. Both sides employ huge drone manufacturing capabilities dedicated to making small FPV drones or using money to buy civilian quadcopters on the open market. Dotted across Ukraine are hundreds of ad hoc factories set up in abandoned homes, hospitals, and bunkers where Ukrainian volunteers use a variety of methods to not only cobble together FPV drones from open-source parts, but also modify munitions like anti-tank grenades, regular hand grenades, RPG warheads, and mortar shells so they're able to be dropped from these small drones. For Russia's part, they too have hundreds if not thousands of factories both inside occupied Ukraine and inside Russia producing FPV drones on a similar scale. To put some of the numbers into perspective, the Ukrainian government has set a target of 1 million FPV drones to be domestically produced in the country in 2024. This number does not include the huge numbers of FPV drones Ukraine buys on the open market or that are donated by allied countries every day. Both sides of the conflict use FPV drones for a variety of purposes. They use them to target and take out tanks, artillery pieces, armored vehicles, and worst of all, harass and kill unsuspecting individual soldiers anytime, anywhere. Due to the complete proliferation of FPV drones, coming up with ways to take them out has been a priority for Ukraine. But this has been easier said than done. While Ukraine has been provided with some of the West's most capable anti-air systems, they are not necessarily the best choice for taking out drones. For example, the US Patriot and NASAMS systems, along with European weapons like the Iris-T, are all incredibly powerful, accurate, and versatile anti-air defenses. The only problem is, they're costly to operate. With a unit cost running into the hundreds of thousands of dollars per missile, every time Ukraine fires the weapon, there could be millions of dollars spent per engagement. When firing against Shahid drones with a unit cost in the tens of thousands of dollars, or worse, against an FPV drone with a price in the thousands or even hundreds of dollars, using these highly capable air defense systems is a sunken cost fallacy that Ukraine is on the wrong side of. To counteract wasting precious ammunition on drones meant to exhaust Ukraine's missile supplies and stop the flow of expensive Western aid into the war zone, Ukraine's Western backers have provided a variety of other anti-air systems that the country has put to good use. For example, Germany's legacy Gepard and newer Skynex air defense systems have been donated and proven useful on the battlefield. Utilizing high-capacity autocannons to shoot down short-range, fast-moving targets, these vehicles have downed significant numbers of drones. However, at only around 50 total units operational, these are just a drop in the bucket for what's needed. Ukraine's Western backers have also provided a variety of other air defense systems explicitly geared for drone defense. For example, Lithuania has donated thousands of Skywiper electronic drone mitigation systems. These small portable units are great for point defense of local units that can keep them in a vehicle or trench due to weighing just 14 pounds. The Skywiper works by jamming the radio frequency signals the operator sends to control the drone. But while these systems are great for protecting smaller areas within 3 miles, visible drones outside this range are not susceptible to their effects. Even worse, due to the increased number of GPS jammers on the battlefield, Russia has been hardening its own weapons to become even more jam-resistant, lessening the usefulness of such tools.
Of course, that's crazy, bro. The weapons that are fought with today, you compare them to the weapons that were fought with in the past, it's literally mind-boggling if you look at the difference between the two. It's the technology is just on a completely different level.
Another counter-drone system that Ukraine has utilized is the Terrahawk Paladin counter-drone system. Adapted from MSI's Navy variant for land use, the Terrahawk is very similar to Germany's Skynex. Utilizing a powerful autocannon, it's designed to perform point defense in an area of up to 3 kilometers, using its own radar suite. However, unlike Skynex, the Terrahawk is a static weapon, meaning it cannot move on its own and is very vulnerable to enemy counterfire. Ukraine has also not received very many of this system either. The US has also donated several drone defense weapons, including the new Vampire by L3 Harris. Of all the donated drone defense weapons, the Vampire is the most similar to the Slinger. It is its own self-contained unit fully equipped with radar and a control unit that can be mounted onto most pickup trucks. But unlike the Slinger, the Vampire has a 4-rocket pod that can fire 70mm guided rockets or similar munitions. However, despite being very similar, price and capacity are the main drawbacks. At $27,500 per rocket, the Vampire is still on the wrong side of the math equation when shooting down drones worth $500 each. Additionally, with just 4 rockets, a Vampire system could quickly run out of ammunition in a real fight where multiple drones are coming from different angles of attack. Lastly, reloading this weapon while under fire is no easy task, and when out of ammunition, the operator would likely have to egress the area to reload and get back in the fight. As one can see, though Ukraine has received a lot of Western aid, no single system can yet meet the cost-effectiveness and versatility needed when shooting down swarms of FPV drones. So what are the advantages of the Slinger over some of these systems? Arguably, one of the Slinger's best advantages is the cost. Firing 30mm and 7.62mm rounds, the Slinger can engage a huge number of drones for about a couple of $100 to $1,000 per engagement. Compared to the hundreds of thousands of dollars of some of the advanced systems, the Slinger finally gets Ukraine on the right side of the cost equation. Another pro is that the Slinger is very adaptable to whatever platform the Ukrainians need it to go on. Currently, larger air defense systems like the Patriot come with several modules, including the firing unit, radar, command post, and other containers. These containerized systems cannot move quickly on the battlefield. For other legacy systems like Gepard and Skynex, these systems can cost millions of dollars, plus have expensive maintenance to keep the vehicles operational. Additionally, getting a replacement in the field is tough if the vehicle takes any substantial battle damage. On the other hand, Slinger is much more versatile, in that it can be mounted on a pickup truck, tank, or armored personnel carrier,
that's
or
crazy.
in a static position. With the ability to quickly displace and be replaced due to its low cost of around $1 million, the Slinger beats out the other mobile platforms. Because the Slinger system is so small, its radar cross-section and energy are much lower than those of other air defense systems. Countries like Russia have developed a wide range of emission-seeking munitions that look for radar energy from an air defense site and home in on it. However, because the energy output from this system only goes a few kilometers and is very small, when operating, Slinger is practically invisible to Russian aircraft unless they are right over the top, which would be a whole other problem in and of itself. But despite these pros, there are a few disadvantages to the system that could eventually give the Russians a way to defeat it. One way is its ability to integrate into Ukraine's overall air defense network. Due to the limited range of its radar, the firing unit would have to be able to share data with assets that have a longer range in order to be forewarned for incoming attacks. Not having this capability to share data can leave operators vulnerable and surprised by massed Russian attacks. This ties directly into the Slinger's next con. In Ukraine, it's been increasingly common for Russia to employ ever-increasing numbers of drones in multi-axis attacks against Ukrainian positions. Though the live-fire demonstrations in Australia were impressive, it should be noted that these were all single-drone engagements. Though Slinger could very well encounter single FPV drones since they're so common, it's increasingly more common to see multiple drones at one time. How Slinger will fare against these multi-threat engagements may only be known when Ukraine uses it on the battlefield. But despite these cons, Slinger will undoubtedly be a game-changer on the battlefield, filling a hole in Ukraine's air defense network. But what do you think? Do you think the Slinger will change the dynamics of drone warfare on the battlefield? Let us know in the comments below. Also, tell us what other military technologies you're interested in learning about. Don't forget to like this video and subscribe to our channel for more expert military analysis and updates.
It sounds like the Slinger is definitely the best weapon against these drones due to the cost effectiveness of it. It's just, everything else just sounds too expensive. Even if it may be a better weapon, it's too expensive. So the Slinger definitely just sounds like the best weapon, cost effective, and versatility is crazy. We'll see how it goes. Anybody got an update on it and know how it's going, or has it gotten to the Ukraine yet? Or I'd be intrigued to know. That's all we have for this video. If you guys enjoyed that one, make sure you check out this one next. Subscribe to the channel, ring the notification bell. It's your boy Neal. Out.